basically the same, but it has some imaginary roots. How can
Was the plus x minus 4 part of the equation?
I think it was.
Oh, yeah.
Yeah, it was. It kind of came out weird, didn't it? I copied that out of the book. I don't know why that popped out like that. If you didn't do it, we'll do that part together. How can I tell if an equation, a function, has imaginary roots? Just by looking at it.
It doesn't have the same number of roots
As the x. When I graph this, if it doesn't have the same number as it crosses through the x, good, then it's going to be imaginary. Now, how many roots did I expect this guy to have? 3. I should get 3 roots, 2 terms, 1 inflection point. So my 3 roots, I should have seen this cross 3 times, but I only see it once. That means the other set is imaginary. When the other set is imaginary, it has to be a conjugate pair. Like your radicals, coming from a quadratic, coming from complete the square, or you could even get this. This is the same thing. This is the same thing as if you did the complete the square or a quadratic. So I need to find 2 other roots, and they're going to be imaginary. Now, if you missed this, I'm sorry. I don't know why it printed that way. But when you do your synthetic division, start with 1 root. If you graph this, you can get this root. If you can't get this root, you're not going to be able to go any further. So I won't do that to you. I'll either give you the root, or you can find it in your graph. I wouldn't expect you to figure out how do I get this. Even a fraction, sometimes if I don't give you a root and you do see it cross the x-axis, do a zeros on it and see if it's a fraction. Because a fraction is okay to use too. So we do synthetic division and we come out like this. Is everybody okay with taking out the -1 for I? Did you guys do the imaginary numbers last year? Okay. So when I'm here, I can't take the square root of a negative number, and -1, radical -1 is the I. So we're just going to say, don't forget the plus or minus, and those 2 imaginary roots are plus or minus I. Okay, so we have 1 real root, 2 imaginary roots. This is the only time we work in imaginary numbers, is when we do this. We have no use for imaginary in our normal parts, but when we get to here, we have to have a way of saying where those roots are. So those are imaginary, which is probably why someone came up with the imaginary root, because when you do your quadratic, and you do this piece in here, and the rest of it is all here, when you plug this in, if this was a negative, you'd be stuck. You wouldn't know where to go. So they came up with an extra number system for this. So that's why we use your imaginary. I just put this, and I just kind of rewrote it as, I guess it didn't say to rewrite it. I just rewrote it in terms of, if I gave you this root, this is your x minus 4. If I gave you this, how do you tell me this in a root? This would be from here, x squared plus 1. I wouldn't expect you to go from here to here, but if you took it this way, that is your x squared plus 1. When you synthetically divide it, this is your other factor, right? That's your factor. So I just put that factor here. If you FOIL this out, or multiplied it out, it comes to this. I want you to get to the habit of when you do synthetic division, what's left is not an answer, it's a factor. And that's why we try to factor again. For what we're left with, then we can set it equal to 0 and solve for the root, because it is a factor. Good? Stop me if you have any questions. If you're not seeing synthetic division, by all means, stop me. Okay, I expected to see 2 roots, 1 turning point. When it doesn't cross the x-axis when I graph it, I know I have imaginary roots. God bless you. God bless you. I set it equal to 0, and I find my imaginary roots. Your imaginary roots, again, are always going to be a conjugate pair. A plus and a minus with the I. Did you do other things with the imaginary numbers? Did you add, subtract them, multiply, and divide them, and do all those? Did you, on the radicals, did you rationalize your denominators with eyes? Like with your eyes?
So, I don't really remember much of that.
Did you do these
Yeah.
Yeah.
and rationalize?
I have no idea how to do
But I don't
it.
remember how to.
Okay, we're not going to do that anyway right now, but I didn't know how. You would have to, like, if this was a radical, if this was in your denominator, you multiply by its conjugate, right? So you would do the same thing here, multiply top and bottom by its conjugate. Okay, as long as you did stuff with eyes, we're good. Okay, so let's move on here. All right, this one. We graph this, and we see that we expect 4 roots, and we see a cross twice, but we don't see it cross the other time. We get the little W, but it doesn't normally crosses twice. I didn't graph it, but if you sketched it, you'd see 2 real roots, 2 imaginary roots. Can everybody do this, or you want to divide this together? Did I give you one of these, or did you have to find it? Did you find it in your calculator, the roots? Okay, so let's take a look at this. This is what I was talking about. If you can't find it, it's probably a fraction. All right, so when we graph this guy, we're going to see it cross twice, but we can't see anything else. So somewhere our little W is coming out down here somewhere. If you want to take a look at it, you can. You're pretty close to the 0 here. You can look at your table to see where it's going. If you're in your calculator, you can look at the table. Okay, so we can kind of see where it's crossing. Maybe we're very close. You can even set your table set in between 1 and 2. You might see it a little bit better. Go down to like -100 maybe, if you want to see it. All we care about is the roots. I don't really care where it's turning. So somewhere it's turning down there, and these are the guys I care about. Now, if I don't see the 0 in my table, that means, and I can see it over here, it's crossing in between. If you're looking for a 0, find it here. Here's your 0, 2. Isolate it to the left. Just go to the left of that little thing. Then go to the right. Certainly looks like it's symmetric, and all we need to do is find 1. And there's your -1.5. Now this looks like it's a positive 1.5, doesn't it? Do another zeros on it, or do a second calc, and see if that's out there. Be resourceful. And yep, that is. So now I have 2 of them. I have a -1.5 and a positive 1.5. I tend to work in fractions. It works the same if you do a 1.5 in there. I tend to be a fraction person. So we're going to start with this, and we're going to pull these out. So pull out your leading coefficients. I got a 16. What is my x cubed coefficient? I don't have one, so what is it? 0. What is my x squared? 0. What is my x?
0.
I have none of those, so I have to put a 0. So 4, 3, 2, 1, 0. So I'm going to take out my 3 halves. I've got 2 that I can see. I need to find 2. So when I find my 2, it's going to bring me down to an x squared. An x squared, I can do the quadratic, I can complete the square. So that's my goal. So I multiply this, and I get, this goes into here, 8 times 3, 24 times, I add it down. I multiply this goes in here, 12 times 3, 36 times. I multiply it again, I get 54. Now my last one should come out to be a 0, because I know this is a factor. If it doesn't come out to be a 0, something happened. I probably multiplied wrong. So don't move this, do it again, because you now have to take out the second root. So now you're down to a cube. So take 1 more out. And again, repeat your pattern. Multiply left, go to the right. I'm just going to follow that black border. Multiply left, go to the right. Multiply left and go to the right. If this didn't come out to be a 0, I would be in trouble. So now I know I took away 2. So this is going to start with the x squared plus 0x plus 36. Do I need the 0x? No, I just stuck it there so you see what would happen to the x. You have a couple of things you can do. You can put this in your quadratic formula. You can just set it equal to 0, which is probably easier. And divide by 16. Here's where your I is coming out. When you take the square root of this negative number, you're going to get a plus or minus. And take out the I first. And the square root is of 6 over 4. And just reduce it. So these become plus or minus 3 over 2I. So you have 4 roots. You should have 4 roots altogether. And you have 2 imaginaries, 2 reals. Yeah.
Doesn't matter when you divide them, you do, like which root you divide.
Nope. It doesn't matter. You will come out the same. In the end, you will come out the same. You pick which one you like to do. It doesn't matter. Good? So this is what I was saying. Sometimes if you don't see it, it's probably a fraction. I wouldn't give you one that was irrational because you'd never be able to find that root. I'd have to state it. We expect 3 roots out of this. When we graph it, we see 1 real, so we have 2 imaginaries. Our imaginaries are going to be a conjugate pair. So I take out my 0 that I found, my -5, take out your coefficients, multiply left, go to the right, add down. Left, go to the right, add down. There's my 0. So I bring this down to an equation and I say, I gotta factor this, but I can't factor it. If you want to do complete the square is absolutely fine on this one. It works nice. And complete the square. Actually, move the 25 over if you're going to do it that way. And add to this side. Make life even easier. What's half of -8? Good? We add 16, add 16. So this becomes what, 9? 9. And then take the square root, take out your I, move your 4 over, and you get the same thing. My rule of thumb, for me, if this is even, I'll complete the square, so I like complete the square. If it's odd, then I'll use the quadratic. Then I usually get like fractions, I have to square them, I have to subtract them. Then I'll use the quadratic. But whatever one you like to use is absolutely fine. Then list me all your roots at the very end. So you have a -5 and 4 plus or minus 3i. Let's take this guy and go back to our equation. I've got 2 roots, 2 sets of roots. This guy, and I have a conjugate pair. Let's go back to your equation and see if we can get back there. Let's work with the -5 first. What factor is that? X plus 5. Because if I set this equal to 0, I get x plus 5 equals 0. So right away, I can start my equation. And I got to have another one. Something else has got to be in here. It's going to come from this guy. How can I get back to that equation? Sum and the product. So let's put these in your calculator. Trust me, it works so easy in your calculator. Do it like this. They're conjugate pairs. Do the sum. Flip it back down. Do the product. Then you never see a quadratic with an I in it. Because when you multiply these, when you multiply them, your middle terms will go away, but your I times I is I squared. And what is I squared? -1. So my I is going to disappear. So what is my sum? If I add these. 8. So again, let's make A equal 1. So what is B? Negative 8. Now bring them back down and do the product. Just multiply them out. Product says this and this. So I'm going to get 16 minus 9i squared. And I squared is negative 1. So that becomes a positive. So my product is 25. Just do it in your calc. Isn't it easier in your calculator? Got to disappear. And C is 25. So now I found the other factor. God bless you. There's my other factor. Okay? And check it. If you check it on your calculator, you're going to see x minus 5, but you can't find your imaginary roots on your real axis. If you do your imaginary, I don't know if you, did you graph vectors last year? With yi? Okay, so if you graph it, if you graph this number just real briefly, say I just graph 4 minus I, this is my x, this is my y. So it's like 4 and negative 1. It would be 4 here. It actually, we call them vectors when they have imaginary. They have direction and they have magnitude. But that's where your imaginary one would rest, on a yi. You guys might see this in physics. Vectors, direction and magnitude. Some things we took out of Algebra 2, some things we put into Algebra 2. So, physics people got that, the vectors?
Yeah.
We used to add and subtract them using vectors. And then you find your diagonal. You guys do that? Good. Very good. This course will absolutely help you in physics. Absolutely help you. So this one. How do we deal with this one? Okay. Now we're going to do better, right? So we know that this first factor is easy, x minus 3. So now let's use your sum. Your sum of 4i, I'm just going to put these in parentheses because I like you to use your calculator. What is 4i plus negative 4i? Yeah, I put it up here. I started the equation. Isn't 3 by itself, right? So now, for these conjugates, let's come up with an equation. So what is 4i plus negative 4i? 0. So therefore, what is b?
0.
So a is 1, b is 0. Bring it back down and multiply. So what is my product? 4 times negative 4 is negative 16. I times I is I squared, which is negative 1. So 16. So therefore, C is 16. So there's my first one. Here's my second one. And I don't want you to multiply it out. I want you to leave it in factored form. Why? Because it's easier for you to check back to where your roots are. It's easier for me to see it too.
Why wouldn't you include 3
3 is one of the roots. I did include 3.
in the sum and product?
Because 3, it says this, right? How many roots do you have here? This is your conjugate pair. They have to belong together. I could do this. How many roots does this equation have? Ooh, no. No. Oh, if it has a 4i, what does it have to have? It has to have a conjugate. Because where did this come from? How did I end up with an I out there?
Square root.
My square root of negative 1. So where did that come from? Either my completely square or my quadratic. So if I give you this, you have to say, well, I only see 2, but there's got to be one more because this has to have a conjugate. My conjugates are the ones that make one equation. And then my other one, I can just string out those factors.
So whenever you have conjugates, that's why you use sum and product and not the non-conjugate numbers?
It's easy. Well, you can use them. Like if I gave you this, it's for you to do this. But I can absolutely do the sum and product on this. I could say the sum is 5. So B is going to be negative 5. I could say my product is 6. So C is going to be 6. So I get x squared minus 5x plus 6. And doesn't that multiply out to this? Yeah, but it's easier just to take those and set them back. But you can absolutely do that. But then you lost your factors. And I don't care if you give me this or you give me this. It doesn't matter. But when you get to the conjugate pairs, I could do this like this. I could do this. X minus 4i times x plus 4i. This is going to give me x squared minus 16i squared. So it's going to give me plus 16. That one's nice because there's only one term. I could do it with that one too. Get used to using your sum and product for any of your conjugate pairs. It works nice. You got your calculator. Put it in as a plus, flip it back down, put it in as a multiply. And remember, you never see a quadratic with a radical in it. And we never see a quadratic with the I in it. So that has to go away. Make sense? Okay. How'd this one go? So if you didn't do it last night, try it now. Is this the last one?
Wait, you want to leave it like
I just want you to leave it in factored form. However
the
you,
last one?
like this one. I did it out because in case anybody did multiply, I always get 1 or 2 kids that multiply it out, which is great. Which is great. Don't use my work, guys. Just did it that last one. 3 plus I. You have 2 ways to do this. You know what? Let's save this. Remind me on Monday. Let's work this out, okay? Remind me on Monday to work this one out.